China is preparing to deploy humanoid robots at a busy border crossing with Vietnam, marking a significant milestone in the country's efforts to integrate advanced robotics into real-world public operations. Shenzhen-based Ubtech Robotics, a leader in full-size humanoid machines, has secured a $37 million contract to send its Walker S2 robots to the Fangchenggang border city in Guangxi beginning this month. This initiative is designed to test how humanoid robots handle complex environments where schedules are tight, inspections are frequent, and human traffic is constant. The trial is being watched closely by both industry observers and government regulators, as success here could determine whether similar robots are deployed in airports, seaports, train stations, and industrial zones across China. The big question is whether these robots, which are equipped with artificial intelligence that controls a physical body, can reliably navigate a bustling, real-world border crossing while assisting humans in ways that are both safe and efficient. The Walker S2 humanoid represents one of the most advanced robots Ubtech has produced. Standing at adult human size with jointed legs, a torso, and arms, it is capable of navigating spaces designed for people rather than vehicles or machinery. Its design integrates autonomous battery swapping, allowing the robot to replace its own batteries without human intervention, thus minimizing downtime. A combination of cameras, depth sensors, and force feedback mechanisms in its joints enables the Walker S2 to maintain balance, avoid collisions, and adjust its movement in response to unpredictable surroundings. These capabilities position it closer to a general-purpose worker than traditional single-task industrial robots, which are often confined to predictable factory floors. In the context of a busy border crossing, this means the robots can interact with vehicles, luggage, and travelers while maintaining stability and safety even in crowded or chaotic conditions. At the Fangchenggang border, the Walker S2 robots will take on a variety of roles that augment human staff. They will guide passenger queues, provide directions, and answer basic questions, reducing the need for officers to repeat routine instructions. Some robots will patrol waiting areas, corridors, and inspection lanes, monitoring crowd patterns and blocked exits to alert human personnel when intervention is needed. In cargo sections, robots will assist logistics teams by scanning container IDs, verifying seals, and transmitting status updates to dispatch centers. Beyond the border, the Walker S2 units are expected to work in industrial environments, including steel, copper, and aluminum facilities, where they will follow structured routes in hot and potentially hazardous yards. This versatility underscores the value of humanoid robots as adaptable tools capable of both public service and industrial applications. Ubtech Robotics has previously deployed Walker S2 units in factories and data centers across China, making the Fangchenggang project its most high-profile public deployment yet. In total, 2025 orders for the Walker S2 series, including domestic projects and the September procurement deal, amount to around $157 billion, demonstrating significant market interest in humanoid robots despite the company still operating at a loss. Scientists at Ubtech emphasize that these deployments are intended to demonstrate practical value in real-world scenarios rather than just boosting order numbers. For the Chinese government, humanoid robots are considered a strategic sector. In 2023, the Ministry of Industry and Information Technology issued guidance calling for a national innovation system around humanoid robotics by 2025, including the creation of a technical committee for standardization. The Fangchenggang trial aligns with this agenda, as it allows regulators to monitor safety, reliability, and accountability in a controlled yet realistic setting. Training the Walker S2 robots has been a critical component of their preparation for border operations. A dedicated data training center in Beijing's Shijingshan district, spanning 3,000 square meters, roughly 32,000 square feet, hosts over 100 humanoid machines in simulated workplaces. Here, robots practice tasks such as assembling parts in mock workshops, cleaning, making beds, tending small indoor gardens, and navigating complex environments to collect data on movement and interactions. These training exercises are designed to ensure robots arrive at operational sites with tested skills, rather than relying on trial and error. Research in industrial robotics emphasizes that perception systems, including cameras, depth sensors, and other detectors, are crucial when robots and humans share the same space. These systems allow humanoids to recognize people, avoid collisions, and adjust behavior dynamically, which is particularly important at a border where travelers and cargo move unpredictably. For travelers at Fangchenggang, the introduction of humanoid robots will likely be one of the most noticeable changes. Passengers will encounter machines that can talk, point, and provide basic directions, sharing inspection halls and queues with human officers. In theory, this will allow border staff to focus on more complex tasks such as identity verification, risk assessment, and investigation of suspicious activity. Some travelers may appreciate shorter wait times and clearer guidance, while others could feel uneasy at being observed by humanoid robots capable of recording movements and interactions. For border personnel, the deployment raises practical questions about training, authority, and accountability, especially if a robot malfunctions or misidentifies a situation. These operational considerations are as important as technological ones, as they will determine whether the integration of humanoids enhances overall efficiency and safety. Despite their advanced capabilities, Walker S2 units face real-world challenges at an outdoor, high-traffic border. The robots must maintain balance, operate reliably in diverse weather conditions, and navigate complex human and vehicular interactions. Additionally, policymakers and planners are closely evaluating whether such systems provide economic benefits once hardware costs, software development, maintenance, and supervision are factored in. China's economic planners have cautioned robotics companies against overpromising and overbuilding, emphasizing the need to avoid hype and potential market overcapacity. The Fangchenggang trial will provide critical data on these aspects, determining whether humanoid deployments can be scaled across other borders and critical infrastructure sites, or if stricter oversight will be required. The deployment of humanoid robots at the China-Vietnam border represents a significant step toward integrating AI-driven machines into public operations, combining advanced robotics with strategic policy goals. Successful operations could pave the way for similar deployments at airports, seaports, and train stations, where automation may reduce human workload and enhance efficiency. Conversely, any failures could lead to increased scrutiny of both technological capabilities and regulatory frameworks. As UB Tech and Chinese authorities monitor the robot's performance, the trial will provide insight into the potential of humanoid robots to perform meaningful tasks in dynamic, real-world environments, balancing operational demands, human safety, and economic sustainability. The results of this trial could shape the trajectory of humanoid robotics in China and globally, offering a glimpse into a future where humans and robots collaborate closely in everyday spaces.